quick review of basic similarity and the concepts within similarity. We're going to be going through scale factors, similarity tests, and scale drawings. So let's start off very quickly. Let's start off with the similarity tests. So similarity test 1 states that if two angles of one triangle are equal to two angles of another triangle, then the two triangles are similar. So for example, if I had two triangles drawn, and I stated that this was 60 degrees and this was 60 degrees and this was 40 degrees and this was 40 degrees, then I can see that the two angles match the two angles of the other triangle, meaning that these two triangles are similar. So test number 1 is quite simple, two angles matching two angles of another triangle. Let's go through test number 2. Test number 2 states that if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. This also means that the matching angles are also equal. So for example, if I had two triangles as such, and I stated this was 6, 12, 24, 48, 36, and 60, 120, 72 actually. So here we have our two triangles. Now the test says if the three sides of one triangle are proportional to the three sides of another triangle. So here I can see 6 to 12 is doubled, 24 to 48 is doubled, and 36 to 72 is doubled. Now because all three sides are proportional to the three sides of another triangle, then these two triangles are similar. Now that also means that, for example, if this was 40, 60, and 80, then we can also say that the other triangle, without looking or knowing, that this will also be 40 degrees, 80 degrees, and 60 degrees. So remember, test number 2, if the three sides of one triangle are proportional to the three sides of another triangle, then the triangles are similar. Also, their angles are also equal. Let's go on to test number 3. Test number 3 for similarity states that if two sides of one triangle are proportional to two sides of another triangle and the included angles are equal, then the two triangles are similar. So let's do an example of that. So we have two triangles and we can state that this here is 40 degrees and 40 degrees. Now, for this test to be true, both triangles have to share the same angle, but two sides have to be proportionate as well. So we could say that this is again 6, 12, 24, 48. Now we can see that this angle is the same as this angle. This side is proportionate to that. That side is proportionate to that. So they are similar. So test number 3 is that they have to share the same angle and they have to have two sides that are in proportion. Let's go to test number 4. Test number 4 states that if the hypotenuse and a second side of a right angle triangle are proportionate to the hypotenuse and a second side of another right angle triangle. Now let's go through this and let's simplify it. I have two right angle triangles, which means that they are both 90 degrees. So I know that they both share these 90 degrees, which is an angle. And if it states that the hypotenuse is proportionate, so let's say this is 6 and that's 12, and the other side is also proportionate, either side, it doesn't matter which one. So let's say this is 8 and 16. Now we can say that they both have right angles and they both are proportionate with the hypotenuse and they're both proportionate with either side. They are similar. So they are the 4 similarity tests. You need to memorize these and you need to know them for later on. Let's go on to enlargement and reduction factors. Now here I have two triangles which I say are similar because their sides are in proportion. Now in order to get enlargement and reduction factors, let's start with the enlargement factor. And in order to get the enlargement factor, I have to see if I have a smaller triangle, what scale or ratio would I multiply it by to get the larger triangle? So in order to do that, I get the larger number of any of these sides. I can pick the 6, I can pick the 12 or the 24, it doesn't matter. Let's pick the 6. We go 6 over 3. So we say in order to enlarge it, we pick the larger side, 6 over 3. And when we do 6 divided by 3, we get 2. That means that whatever the side is of a smaller side, let's just say this is 12, I have to times it by 2 to get to 24, to enlarge it. Now let's go to the reduction factor. When I need to reduce the scale of the drawing, this is the same except it's the other way around. So we do 3 over 6. And when we do 3 divided by 6, we get 0.5. That means whatever the larger number is, I can divide it by 0.5 to get that. And opposite times by 2. And there I can figure out my enlargement and my reduction factor. Now sometimes you'll have to find an unknown side using similarity. Here we can see is stated in the question that these two triangles are similar. Now I need to find the value of x. So I look at its matching side. So here, the matching side of x is 3. So I can do x over 3 equals 160 over 21. Now in order to find the value of x, I can use ratios, but I prefer to use cross multiplication. So I'm going to cross multiply. I'll use two different colors. X times 21 gives me 21x equals 160 times 3. And 160 times 3 gives me 480. So I just simply place that, and that we call that cross multiplication. Now, going back to equations, in order to get x by itself, I need to divide both sides by 21, which cancels that out. Now I'm left with x equals 480 divided by 21, which gives me 22.86 dp. Now I don't have any units here, so I can't say that, but now I know the value of this x is 22.86 dp. And I use that using this cross multiplication technique here. Let's go on to the last type of question, which is scale drawing. Now, scale drawing is quite simple when you understand how it works. You use a lot of scale drawing in maps or geography or architecture or any of those concepts. So let's have a read of the question. It says, a scale of 1 to 250 is used on the map. We measure 27.5 centimeters on the map. How much would this be in real life? So I can use my scale of 1 to 250, but this 1 is now 27.5. So I have 27.5, and in order to get it to its real life, which is times 250. So I do 27.5 times 250, and I get 6,875. That means that if on the map it says 27.5, in real life it's actually 6,875 centimeters. And in order to convert this into meters, we divide it by 100. You can always simplify it. 68.75 meters in real life. So this is quite important when we're doing any architectural drawings of something that's too large, etc. So I'd like you to go through and understand all these concepts. If you have any further questions, please let me know. Thank you.